Hello and welcome to lesson 29. Today we are going to see an epic battle between Sir Isaac Newton and, what's his first name? Gottfried Leibniz of the 17th and 18th centuries. It's pretty cool. So at the exact same time, this is so cool, Newton was working on calculus, and somewhere else completely on the other side of Europe, Leibniz was working on calculus. And as they were both developing it at the same time, they both decided that they would write their notations a little bit differently, because obviously calculus hadn't been invented. So what happened is Newton wrote his differentials or his derivatives like this. So you would write the derivative, or f prime, of x. And the second derivative would look like this. A third derivative would look like this. If you ever take physics, f dot would be the derivative with respect to time, f double dot, second derivative, f triple dot, third derivative with respect to time. So, or you can just write it like this with t. Leibniz was like, he chose a different approach to describe the derivative. He said the derivative of the function y by dx. When you take the second derivative, you take the derivative by dx, or whatever with respect to you're doing. Unfortunately, when I was in school, I loved Newton's way of writing. But as I've grown older, I feel like Leibniz notation gives you a little bit more information. It allows you to see dy's and dx's. It also allows you to do our problem set today. This would be d squared y by dx squared. Our problem set today, which would be nearly impossible using Newton's notation. So, they're going to give you problems that look like this. Y equals 3x to the negative 2 plus 2x squared plus 1, and they want us to find dy. So the trick is this. When you take the derivative of y, then you get a dy. When you take the derivative of a function that has x in it, you get a dx. Derivative of y, dy. Derivative of x, dx. So let's take the derivative here. I bring down the negative 2, so I have negative 6x to the negative 3 dx. So you take the derivative and then you append, or you put dx afterwards if you took the derivative with respect to x. Okay, so each term we're going to keep track of what we're taking the derivative with respect to. Taking the derivative of 2x squared is 4x, and I took the derivative with respect to dx, so I put the dx there. Take the derivative of 1, that's 0, so I need nothing. So this would be my answer if they want to know dy. Usually we'll want dy by dx, so I can divide this entire equation by dx and solve that way. Let's try another one. If we have y equals sine of t plus cosine of t, I am to find dy. We'll do the same thing. What's the derivative of sine? Well, it's cosine. dt, because I took the derivative with respect to the variable t. So I append dt. Here, I take the derivative of cosine, that is negative sine, and again, dt. If you want, you can factor out the dt's and write them like this. That's fine as well. And it must have been a good day for golf, because that, my friends, is lesson 29.